Alright guys, so today I'm out with an excellent substitute teacher. So what we're going to be doing today is we're going to be taking a series of notes. Our notes are going to cover Earth's place in space. So a couple of the topics we're going to learn about today is something called the Goldilocks zone, which explains why life on Earth is capable in the first place. The other topics we're going to be covering is the reasons for the season. So we're going to learn about seasonality. We're going to learn about why some areas of the globe have a summer, some have a winter, and we're going to learn about why some places have neither. Some places don't have seasons. They have a wet and dry season, but they don't have a traditional winter or summer. So to get us started today, we're going to begin with a video, and the video is going to talk about an area called the Goldilocks zone. So on your paper, you have 8 characteristics that are most significant and unique about Earth that we think allow for life to exist. So while we watch the video, I'm going to pause it every once in a while because the video goes a little bit quick and I want you to write each thing down. At the end of the video, we'll review and there'll be a slide with all of the correct answers filled in. So at the end, all the slides will be filled in. So if you don't catch a term, don't panic, don't worry. We'll go through the video first, then we'll review the Google Slides to make sure that you were able to catch everything. So in a second, I'm going to start the video. So make sure you have a pencil out. Generally, what you're going to be looking for is the title of that section. So the first one is going to talk about distance. So there'll be a title at the bottom of the video. You'll want to make sure that you write that down when the video starts. Okay, so I'm going to start the video.
We find that we need to be at the right location in the galaxy, that we're inside the circumstellar habitable zone of the star, that we're in a planetary system with giant planets that can shield the inner planets from too many comet impacts, that we're orbiting the right kind of star. It's not too cool or not too hot, that we're on a planet that has a moon that can stabilize the tilt of its axis, that we're on a planet that's a terrestrial planet, a planet that has a crust that's just thick enough that it can maintain plate tectonic activity, that has enough heat in its interior that it's still circulating its liquid iron core so it can generate a magnetic field, that has an atmosphere that has enough oxygen to allow for complex organisms to survive, that has enough water and enough continents to allow for the diversity of life or an active biosphere that you need to support complex creatures such as ourselves. All these factors have to be met at one place and time in the galaxy if you're going to have a planet as habitable as the Earth, which you need for complex and even technological life. Internet.
Okay guys, if you didn't catch everything from the video, let me catch you up right now. So going back, the first condition that has to be met is that the planet has to be the correct distance from its star, just the right temperature. It has to be the right temperature. If it's too close or too far away, then we don't think life can exist. We think that seasonality is really important, so it has to have seasons. Seasons are a really important thing for the evolution of species. We have to have some places that's cold, where we can have cold adapted organisms, some places where it's hot, where we can have more hot adapted organisms. So we think the distance from the star is essential. Another factor that we think would have helped us with our Earth being able to house life is the giant gas planets. Those giant planets shield our planet from a lot of debris in the solar system. So it shields us, protects us. The other component that we think has to be met for there to be complex life similar to ourselves is the type of star. Our sun is a spectral type G2 main sequence star. What that means is our sun is the right size, the right temperature, and we think that matters. If the sun is too massive, then that's going to change the habitable zone. Certainly isn't going to make it impossible, but it's going to change how we think of things. The fourth factor is a moon. We think that the moon has to be large enough that it can stabilize the planet's tilt. So if our moon wasn't in place, our Earth would wobble back and forth more than it currently does. Our Earth has some wobble, but the moon is keeping our planet in place. Um, our moon is helping with our Earth's tilt also, so it's helping us with our seasons. Um, and another factor, number 5, is terrestrial planets. Currently, we have no evidence of life on any other planet. So the only type of planet we think that life can live on is terrestrial planets like our own. Um, a lot of scientists think that plate tectonics is essential for there to be organisms. We have to have an iron core, specifically on our planet, an iron outer core, a molten iron outer core. It has to be hot enough that it can generate a magnetic field, but not too hot, because if it's too hot, then magnetism can't exist. Another factor is an atmosphere. The planet has to be oxygen rich because that's what life on Earth generally requires is oxygen that can provide and sustain climate protection. And the last thing is liquid water. Um, we believe that life would have originated in the water, so we think that that has to be one factor to sustain and support life, that at one point in the planet's history there had to have been liquid water. And lastly, a dynamic ratio of water to land. So hopefully you were able to get each of these terms written down. There are 8 of them. If you haven't, if you could please rewind the video so that the students can catch up. Thank you so much. The next piece of information we're going to talk about, which we've already gone into some depth about currently, are terms like revolution and rotation. So revolution refers to the amount of time it takes for our planet to orbit the sun. Our Earth's revolution is 365.24 days in a slightly elliptical path. So what an elliptical path means is if we look at this diagram below, the Earth is not going to orbit around the sun in a completely perfect circle. It's going to orbit in something called an ellipse. You can kind of think about an egg shape for that. So it's forming this kind of nice egg shape. So our Earth is not going to go around in a perfect circle. The length of time that it takes us to orbit our sun is also known as a year. And since it's 365.24 days, as you guys might remember from the reading we did a little bit back, that 0.24 days, we have to add that every 4 years into what's called a leap year. So we do take that into account. So a leap year is going to be a year that has 366 days rather than 365 days. So the distance between the sun and the Earth stays relatively constant throughout Earth's orbit, ranging from 147 million kilometers at perihelion, that's the closest, to 152 million kilometers at aphelion, that's the furthest. So the Earth does change its distance from the sun. Sometimes it's a little bit closer to the sun, sometimes it's a little bit further away. A common misconception I see students make is that they believe that the Earth's distance from the sun is what causes the seasons, but that's actually incorrect. As we'll learn later, that the main cause of the seasons is going to be Earth's tilt as it's going around the sun. It's not actually the distance. So looking at this next image, we have those 2 terms. So the Earth is going to change a little bit in its distance from the distance of the sun. As you can see here, there's going to be times amongst the year, or in the year, when the Earth is going to be closer, perihelion, and we're going to be at times further away, aphelion. So those are what those 2 terms mean. There's parts in our Earth's elliptical orbit where it's further away, and times when it's closer. The other term, so we just learned about revolution, and if you recall, revolution was the length of time it takes for the Earth to orbit around the sun, which was 365.24 days. Earth's rotation is going to refer to the length of time it takes for the Earth to spin once on its axis. It takes our Earth approximately 24 hours to spin one time. In that 24 hours, we have our familiar day-night cycle. Um, right now, the day length is a little bit shorter than the night length. So nights are just a little bit longer, but that's going to be changing in 5 days. On March 20th, we're going to be going to our equinox when night and day are both 12 hours. So we say it's daytime when the side of the planet you are facing is facing the sun, and nighttime when it's facing away from the sun. As we have seen throughout our lives, it's warmer during the day because the light from the sun is going to heat up our surface, and nighttime is generally much colder because we no longer have light. Sometimes you'll hear the Earth referred to as an onion. Our Earth is going to have many different layers. It has a crust, a mantle, an outer core, and an inner core. The mantle we think is thick and molten, and it causes the Earth to bulge around the equator as it spins and also to wobble slightly. The wobble is relatively slight because the Earth is stabilized by the moon. So our Earth, similar to our moon, is not actually a perfect sphere. A lot of times you'll see it represented as a perfect sphere, but it's not. In fact, our Earth kind of has a weight problem. It's going to be bigger around the equator, so it's going to have more of kind of a chubby equator and be a little bit skinnier at the poles. And we think this is due to the liquid mantle. Now, as you guys might have remembered from the video clip we just watched, our Earth's wobble is kept in check by the moon, and we do think that that is one of the conditions that must be met for there to be life. Another thing you might remember that we've talked about is the importance of Earth's magnetic field. So the Earth is constantly being bombarded by solar radiation. We're being bombarded with gamma rays, X-rays, UV rays. Many of these more harmful types of radiation are being absorbed by our Earth's magnetic field. You can literally think of it as a force field because it's a field of force that's going to be blocking our Earth from receiving these more dangerous forms of radiation. When the original astronauts went into space, this was a major concern because they were going to be traveling out beyond Earth's magnetic field, and so we were afraid that they were going to be experiencing radiation from the sun. And in fact, astronauts that do spend long periods of time out in space do experience lots of harmful radiation. So we think the flowing liquid metal in the outer core of the Earth results in the formation of a strong, protective magnetic field that protects our planet from harmful solar winds of dangerous particles. And this graphic is showing the bulge. Our Earth is a little bit chubbier at the equator than it is at either the pole. So it's more pushed in at the top and the bottom, and chubbier in the middle or at the equator region. So we're going to move into Earth's tilt, which is 23.5 degrees. So our Earth is tilted at the north and south pole. And it looks more like this. If you remember, I've walked around the classroom before with the globe. You'll never see a globe that is perfectly, that isn't tilted at 23.5 degrees. If it is, it's a very incorrect globe. But our Earth has a tilt on its axis of 23.5 degrees. We think that what gave us our tilt might have been the early Earth and having a Mars-sized object like we talked about striking the Earth. That would have changed our planet's tilt, we think, to this 23.5 degree amount. So we think this collision likely is what caused our Earth to have its tilt. The tilt is really important because it allows us to have seasonality or seasons. The light from the sun is going to strike the Earth in different spots. So if you live on the equator, then you will always receive the same amount of light year in and year out. So the temperature in places on the equator doesn't really ever change. Places further on the globe, or further north on the globe and further south on the globe, are going to experience dramatic seasons. Living in Santa Barbara, we don't necessarily have the intense seasons that some places do because we're actually somewhat close to the equator. So what goes on is solar energy travels in a straight line. So only the side of an object, like the Earth or Moon, facing the sun is illuminated given light. This means that solar energy hits different parts of the curved Earth at different angles, more directly at the equator and less directly at the poles. So because the sun's light is going to be striking the equator more directly, that means that the equator is going to be receiving more energy from the sun, which leads to places on the equator being really hot. Places at the north and south end of our globe are going to receive less direct light, which is going to cause them to be colder. So an important thing to consider is seasons. So seasons change. So right now we are in our winter time, soon we are going to be in spring. But if you were to go to the southern hemisphere, it's experiencing the opposite season. So when it's winter in the northern hemisphere, which is where we live, the southern hemisphere is going to be experiencing the opposite season. So they would be experiencing summertime. So if you are planning a trip to the southern hemisphere, it's generally a good idea to go when it's winter here and summer there, so that you can experience nicer, sunnier, hotter weather. So during summer in the northern hemisphere, the axis of the Earth is tilted towards the sun, resulting in more direct sunlight. So when it's summer in the northern hemisphere, as you can see right here, the Earth or the globe is going to be tilted in the direction of the sun, causing it to get more direct sunlight. If you look at the opposite end of the globe, the northern hemisphere is going to be tilted away, causing it to be in winter, and the southern hemisphere to be tilted towards the sun, causing it to be in summer. So once again, northern hemisphere in this image is tilted towards the sun, so the northern hemisphere, the United States, is going to be in its summer. The southern hemisphere, South America, Africa, is going to be tilted away, so it's going to be in their winter. Both the northern and the southern hemisphere have something known as an equinox. The equinox falls generally around the 20th of September and March. The date does change. During an equinox, that's when the light hours are 12 hours and the nighttime hours are 12 hours. So there's 2 equinoxes in a year. The summer solstice down here is when the daytime hours are the longest and the nighttime hours are the shortest. So June 22nd approximately is the longest day of the year. It's when we receive the most daylight hours and the least nighttime hours. Winter solstice is December 22nd. It's when we have the longest night and the shortest day. So, referred to it earlier, but equinox means equal, equal night, and on this day the length of the day and the night are the same. Solstice is the longest period of sunlight. So summer solstice, longest day, winter solstice is the shortest day and the longest night. Okay guys, so that's going to be it for the notes today. Remember, what I'd like to have you do now is I would like to have you do a summary and reflection. Remember, we're going to write our summary and reflection based off our essential question, which today is going to be, what are the unique characteristics that allow life to exist on Earth and not on other planets? So go back to what we wrote down for the Goldilocks zone in the very beginning, and I want you to summarize the conditions necessary for there to be life. After you're done with that, we're going to do kind of a creative writing session. I want you to describe your favorite season indirectly without stating what the season is. I want you to be creative. So I want you to talk about your favorite time of the year. So if it's spring, you're going to write a short creative story about spring. We're going to be talking about maybe what you would see, what you would experience outside, maybe what sorts of sports you would be playing. So I want you to get creative with this, but I don't want you to ever say in your paragraph directly what the name of that season is. So if I was writing about spring, I would make sure not to include the word spring in my narrative. When I come back tomorrow, I'd like to have some of us maybe read our stories out loud, and I'll have a story for you guys when we do that. So thanks again, guys. Thank you for completing the notes. And let's get to the essential question and season writing now.